All right, so today we're going to be talking about linear inequalities and a specific type of linear inequality where it's called a compound inequality. And what that means is that we have more than one of them. And what we're going to do is we're going to do specific words, which is and or. Now, these and ors really are very similar to the ones that we do in English. So and means both at the same time, or means one the other. But in math, it means one, the other, or both. Okay? And the reference that I like to use when explaining ands and ors is based off of sort of a little experiment that your parents may have done with you when you were a kid. So, for example, you went to school, you got straight A's, and your parents said that if you get straight A's, they'll give you a car and money. So what happens if your parents give you the car and not the money? Did they lie to you? The answer is yes. Similarly, if they only gave you the money but not the car, then they would have lied to you as well. The only time that they do not lie to you when they're talking about an and is if they do both. So both of them is what and is referring to. Now for math, or is one, the other, or both. So if they say, for example, I would give you money or a car, if they give you just money, then they're okay. If they also gave you just a car, that's okay as well. But if they happen to be very generous, they're like, here's a car and money, then they also did not lie at the same time. Okay? It doesn't matter how happy you are with the results, it just means you have to do one, the other, or both for or, and has to be both at the same time. So remember those references, because when we look at this, that is going to tell us how these answers are going to be formulated. So let's first look up at these very basic examples. The x values which are below 2, but not equal to it, it's going to have an open circle. So, and then the numbers which are smaller, so to the left of 2. The numbers x which are greater than 5 or above 5 is again an open circle, and the parts that are above 5. Now, similarly with this graph, the x values are above or equal to 2. So this allows us to have this equality at the 2 here, and then above. And then x is below 5 is open, and then to the left of 5, which is below. So remember, let's look at the reference words and. So what this is basically asking you is to solve this type of inequality. So we want both of these things to work at the same time. So what you do is you first draw this graph, and then you want to see where this happens. So where does this line, which is the red line, there should be a 2 there. So where does this inequality, which is the blue one, and this inequality, which is the red one, happen both at the same time? And can we see based on this picture that right here the blue happens, right here the red happens, but neither or no parts have the red and the blue at the same time. So this one never happens. And as we know from some of our previous examples, that means no solution. Okay. Now the or is a little bit different, right? The or allows us to have one, the other, or both happen. So we already said that both cannot happen, but we can have the ability to have one or the other. So notice that one happens here, which is the blue one. The other happens where the red is, but neither of them happen at the same time. So this interval, negative infinity to 2, this is where 1 happens. We always connect our intervals with a union. And then it starts again, reading from left to right, it starts again at 5 and goes up to infinity. And this one is the other. So where one or the other happens. Now you'll see that it is different when you're talking about that inequality on the right-hand side. So the inequalities over there, again, for this one is and. So where do both of these happen? Where does the blue and the red happen? And that happens right there. So that is where the overlap is, right? Where the blue and the red are. So this happens starting on the left. It starts at 2, and goes up to 5. And does everyone agree that the left-hand side, the 2, is or equal to because it's closed here? So we are allowed to have brackets here, while the other one, number 5, is an open one. And then lastly, the or, right? If we wanted to change this to or, this happens where one, the other, or both happens. So the part where only one happens, can we see, is right there, which is negative infinity up to 2. The part where both happens is right in the middle, which is 2 to 5. And then the part where the other one happens is from 5 to infinity. Now I write this out not because you actually need to do this, but so everyone can see that this still follows that same wording that we use for or. This is in one, the other, or both. And what this does together is gives you everything because there's no holes, right? It goes from negative infinity, including 2, up to 5, including 5, and up to negative to infinity. So all real numbers are solutions. And we write this as negative infinity